Welcome to Snark Chocolate, a show about ZK products where we break them down with rich flavors and sweet insights. My name is Omer, and I'll be co-hosting this episode together with Queenie. Today, we are thrilled to be joined by Vanishree Rao, founder and CEO of Fermah, the Universal Proof Market. Vanishree, thank you for joining us today.
Great to be here, Omer and Queenie. Thanks for doing this.
Can we start with a brief introduction? What is the vision of Fermah?
Sure. The vision of Fermah is to make ZK adoption as easy as possible for developers. And we believe that there are two hindrances, right? One is the adoption hindrance, and the other one is the ongoing hindrance. The adoption hindrance is how do you code up your ZK circuits? That is solved using ZK VMs to a great extent. The ongoing hindrance is the cost and time of proof generation. And how do we solve that? It is through a proof market where there's competition, where there is the right kind of matching between the demand and supply um, to ensure speedy proof generation and to ensure machines are utilized almost to the max, whereby you can keep the prices down. That is the part of the problem we are solving, because our higher level vision translates into this mission of solving this problem of ongoing hurdles in adoption of CK through universal proof market.
Sounds great. So let's start from the basics. We are talking about this very exciting topic of proof of marketplaces. Can you define, not sure by the way if there's like a good definition, but for the sake of this conversation, can you define what is a proof of marketplace and who are the different actors?
Sure. A proof of marketplace I think it's a very good question, because I think we have been talking about this whole notion for years without a proper definition, and I'm so glad we are talking about this. So this is how I define a proof market or even a prover network. It is a two-sided marketplace. On the supply side are machines that can generate proofs, and on the demand side are people who want to request proofs. And there are these are the two sides of the market, and in the center is this orchestration engine which decides which job gets to which machine, how much each job will need to pay to get it done, how much each machine will get paid. There are so many other aspects of mechanism design that can happen, and all of that is taken care of by this center. And in Fermah, we call it the Fermah core, which takes care of the mechanism design, the orchestration. That I think is my definition of a proof market. And a universal proof market is one which can generate proofs for any proof system. And I think this is just the right way to do for two reasons. One, because you can increase the utilization rate of machines on the supply side whenever you have diverse demand, which is necessary to keep the prices down. And the second is, this is just computation. There are some peculiarities of ZK that we use when we are building the mechanism design, but all in all, this is a computation that has somewhat predictable proving time and has soundness, the verifiability. So these are the peculiarities we use of ZK, but other than that, it's just a computation. So why not focus on just one proof system when you get the real benefit of bringing down the price by working with diverse demand.
Vanishree, I think it would be helpful if you can walk us through the data flow of a proof request end to end so that maybe we can understand the full picture better.
Data flow of a proof request, sure. So when a proof request comes to Fermah, the way we capture it differs from seeker to seeker. For example, with ZK Sync, or with scroll, we may have different adapters between our marketplace and their system. One way is us polling for an event, and the other way is them pushing uh, the proof request directly to our system. So once it enters into our system, you have this mempool of proof requests, and the mechanism design kicks in, and it allocates to the right machine. Once the machine finishes, it comes to the Fermah core. We do the verification internally to make sure it is done. The proof generation is correct. We run the verifier for that proof system, and we send the proof back to wherever the seeker wanted us to send.
So it's more on the downstream of the whole value chain.
Say one more time, please.
So I mean, the marketplace sits on the downstream of the
Right.
whole proof value chain.
Right. So I think if we want to look at where we are positioned with respect to other elements in the stack, so the verification layer or the settlement layers comes right below us, and aggregation layer could come also in between us and the verification layer. But I really think that aggregation is part of proof generation because it's just another proof generation, and it has to have a mechanism design just like any proof generation should have a mechanism design. So I really put aggregation, proof aggregation, as part of proof generation component in this stack. And yeah, before this is the other parts of the stack, the application, or maybe that protocol in ZK rollup. It's the sequencer coming above us.
So is the goal of the proofs generated is to end up on some chain?
Great question. I think it really depends, right? And for the customers we currently have, the biggest of the customers we currently have, the ZK rollups, they it goes back to the chain. We are also working with some zk-TLS protocols where it could go to the protocol, it could go to the user, and then the user does something and then sends it to the protocol. We really don't get in the way of the flow of proof for the seeker. They just specify where it should go and it goes there.
So what are you actually testing nowadays on a testnet? I guess that
Great question.
this kind of product requires like special treatment when it comes to testing.
Yeah. Thanks for saying that, because this is not the usual testnet you see, right? This is not like, people will come and any user on Twitter can come and quickly try it out. It isn't the system, at least currently, that is not the system we are testing. We are testing the supply side to cater to demands of ZK Sync, Scroll, Gateway, OT, and folks like that. Now, how do we do that? There are different elements of our network we need to test. One is really how we communicate with the supply side, how we get the proof request. It's just the points getting connected that we need to test. That is currently what we are testing. A few weeks ago, we were testing how operators would feel as they are getting on board. The prover nodes would feel how when they're getting onboarded to our system. What is the experience for them? We really made big strides in improving that experience, and now we are testing the point-to-point connection. And we are very soon. We are going to test ZK Sync, Scroll, and a few other proof systems, proof generation across multiple prover nodes. The interesting aspect about ZK Sync is that you cannot generate the whole thing on one single machine, and it would take probably a day to do that. How do we orchestrate the whole steps of recursion of proof generation across multiple machines while keeping in mind the cost and time? That part we are going to test very soon.
There are a few other design ideas out there. We had an episode with Gevulot a while ago, which didn't really focus on I guess the low-level technical aspects of proof of markets. But I wonder maybe you can share more about like pros and cons of different approaches compared to what you took.
Or yeah, I really think that a heavy auction on both sides is very detrimental for proof market, specifically for proof market. And here is why. There is so much of predictability in this market. Prices may not change that. So let's consider Uber. The demand can change so heavily there. There are they call these hot zones across a city where there might be heavy demand, and they surge up the price, and they attract drivers there to cater to riders. A similar thing can work in our scenario, in a proof market scenario, but not at such an intense manner. Here there's so much of predictability. And what is the result of this predictability? How can we take advantage of this predictability? You can take advantage of this predictability by giving a better user experience to both the sides of the market. Instead of just taking an off-the-shelf mechanism design and throwing it out there, I think really thinking through what is it that the demand typically looks like. If you really stare at it enough, it gives you enough information to change the kind of mechanism design, and that's exactly what we have done. What we have really focused on is two things. One is the UX on both the sides. I'll say more about it, and the other one is how do we keep the cost down. So I'll talk about both these things, and I'll talk about some other approaches that may not work out to achieve these things. For good UX, if you have both sides do auction, for example, like constant for every proof request, you do both sides auction. It's so hard. You need a strategy built on both the sides to deal with an auction based system like that. It is known in the mechanism design has been around for so many years, and it is such a known fact that the system is it's a heartburn invoking system on both sides. We would rather go away from it. Lyft and Uber went away from it. And the second one is, how do we keep the price down? We um, we we care about efficiency a lot more than decentralization. This can be controversial, but I really stand strong on this view. If you introduce decentralization artificially, then you invariably attract inefficiency. That's the price you pay to have a huge amount of decentralization. If inefficiency is the price you pay to have huge amount of decentralization, and that is not the direction that we are going. We are taking the other route of extreme efficiency, and so we are getting into another topic of decentralization now as we are talking about design decisions, but I think this is a super fascinating topic. This is very rarely talked about in our industry. What is decentralization for a proof market, right? Decentralization can mean very different for a proof market, and it can mean very different for a validator set. For a proof market, here is well, so why do you need decentralization for a validator set? You need to be able to catch bad stuff happening, and you assume that there is a good portion of people who are honest, and if something bad is happening, they'll call it out. That is why you need decentralization in a validator set. For proof generation, you have verifiability. I really don't give a damn about how that person generated proof as long as it verifies. They could go to moon and do a somersault and then generate a proof. Nothing matters as long as it verifies. Nothing matters. Now, so why do we need decentralization in a proof market? So what do we care about? We care about liveness. We care about low cost. So CPD is another beast. Let's talk about it in a little bit. But assume that you don't have privacy. In that case, these are the only two things that you care about. You care about liveness. You care about keeping the cost down. Now, what is the right notion of decentralization, if any, to achieve these two things? To have liveness, you just need enough machines. You just need the supply to be slightly larger than the demand at any given point in time. And when we are designing our mechanism design, when we were designing our mechanism, this is exactly what we kept in mind. Where how do we ensure that the supply is slightly more than the demand? There is this alpha parameter that says that this is how much of a slight blow up you'll have on the supply side, and this is this is the steady state you are aiming for. Now, that's how you achieve liveness. Plus, you achieve liveness by ensuring that people will behave per their commitment. If someone says that I will generate a proof, then of course they will generate a proof. Somehow you need to incentivize them. Why do you need to incentivize them? Why did, for example, zkSync not think about incentivizing their current provers? Because those provers are in house. You trust yourself. This is how it works in the entire world, right? You trust yourself. But when you give your work to somebody else, you need to incentivize them to do the work. Right? They had centralized provers so far. They didn't need any notion of incentivization. Now it is a proof market. They give us the proof request. We give the proof request to some random GPU. You need to incentivize that GPU. If the GPU says, "We'll get the proof generated in 1 hour," 1 hour passes, they just forgot to generate a proof. That's not going to work out. You need to incentivize that proof, that prover node to generate the proof. How do you do that? How do you achieve, how do you get around this problem? There are two ways. One is through redundancy. You just have multiple people do it and hope, and you know that, if you say that probably if someone sleeping is 1/3, then you give it to a couple of people and somebody does the proof and gives it back, right? Another method of incentivizing or disincentivizing bad behavior or incentivizing good behavior is by having these nodes stake some money and slashing them if they don't behave per their commitment. Now, that's how we solve liveness. There is no other notion of decentralization coming in. Now, so far we talked about two reasons. One is liveness, and we summarized two things: liveness and keeping the price down. We went through how to achieve liveness. There is no fancy notion of decentralization needed there. How do you keep the price down? You keep the price down by two things. You get the right people on the supply side. You don't get When I say the right people, think about these centralized cloud service providers. They aim for high gross profit margins, 70%, 80%. You don't want them to be coming on your supply side. You want to incentivize people who work with lighter margins of profit. People who had their GPUs for mining, and now these GPUs are sitting idle. Those are the ones you want to bring on the supply side. That is one way you reduce the price. Another way you reduce the price is by mechanism design has said it long ago that established this long ago that you need to bring about a little bit of competition between machines. That's what is stated. A mechanism design has to bring about a little bit of competition, and that can actually keep the prices good. Now, again, what notion of decentralization is there? If you forcibly, artificially bring a lot of machines on the supply side, a huge number of machines on the supply side, and worry about winner take it all situation, I think it's detrimental to the core values of a proof market that you need to offer, which is low cost, high speed, and liveness. Because all these three things can be achieved without that artificial notion of decentralization.
Cool. So, Vanishree, so winner takes all scenario could happen, right?
Could happen, and I don't
Mm,
think it's a bad thing in a
cool.
proof market. And the reason why is that Okay, let's consider a situation where there is a winner take all when there is no proof market. When there is no proof market, a winner take all would mean that somebody comes and shakes hands with let's say ZK Sync, and then they say, okay, great pricing. Let's shake hands. This pricing is valid for the next 3 months. They do all the integration, heavy integration work, and they take months to integrate, and then slowly they slide jacking up their prices. What'll happen? Right? You're in a bad situation. Instead, if they integrate with a proof market like us on the supply side, they come, winner takes it all for the next 3 months. Great. Start of the fourth month, they start raising the prices. Somebody else comes on the supply side. No problem. That is exactly why you need market driven prices. This is a market driven. When you have a transparent market like this, where there is where prices are discovered per the demand and supply, that's the situation where you want to be. This is one of the big reasons. I think this is probably the biggest reason why someone should choose a proof market instead of working with the centralized provider. It's not for censorship resistance. It's because if demand is coming to us, why would we censor any demand coming to us? That is not the reason, but this is the reason why you will need a proof market to be a core part of infra for an ECK project.
Cool. So you just mentioned, for example, the ZK rollups like a ZK Sync. I
Mm.
know some of them have the plan to decentralize the prover. So then is Fermah a part of their decentralized stack? What's the potential scenario here? Like, would they
Right.
integrate with different marketplaces to be decentralized as possible? Or yeah, what's the best scenario?
Yeah. This is how I understand the stance of ZK Sync or Scroll or the likes when they say we want to decentralize this component of the stack. And so I think it means that you don't want to work with a centralized provider. You want to work with a decentralized network of provers. A decentralized network of provers is given by one proof market already, so they can decentralize this stack, this component of the stack by working with a proof market. They may decide doesn't preclude a situation where they can work with multiple proof markets for any reason. But decentralized uh, prover stack comes already by working with one proof market.
Okay, thank you. So I also want to add privacy to the mix, and you recently announced CPD, Confidential Proving Delegation. Can you explain more about this latest announcement?
Right. Yeah, we are super excited about CPD because this is the way we add ZK back in ZK. Um, when you're delegating proofs, of course, it goes to a random GPU, right? And all the use cases we have been talking about so far, ZK rollups, etc., they don't need the ZK property, the zero knowledge property of zero knowledge proofs, and it's fine to just delegate to a random GPU. That is what the base level of a universal proof market does. So far, so good. Think of ZKTLS, ZKID, where witness can have sensitive information, personally identifiable information. You're actually using the privacy aspect of zero knowledge, the zero knowledge property of zero knowledge proofs to achieve the privacy aspect needed in those applications. And so, what do we do for those applications? So far, people have been thinking about client side proving. And here is the big problem with client side proving, right? What you're saying, what client side proving says is that, hey, I know, the current proof systems, current ZKVMs may not run well on your phone or your laptop. Um, I'm going to build this very different proof system, and you have this application. Maybe it'll fit in your phone. Okay, what happens tomorrow? You have to expand your product into a country where phones are flip phones, Nokia phones. What do you do? World, for example, wants to expand into all sorts of countries where people unfortunately may not have access to beefy phones. Also, what can happen next day is a bigger application. Today, the little application can work on this phone uh, using client-side proving. Tomorrow, there is a bigger application. What do you do? The problem is that client-side proving does not scale with the increase in the size of computation or decrease in the size of or the power of the device. You need an architectural change. You need to change how proof is generated to achieve any level of scalability. And the right answer is confidential proving delegation. It just says that, hey, don't make people who have varied degrees of um, device power generate proofs. Don't make them do that. Don't make them go through that bad user experience. Don't make your product be so limited. Instead, change the architecture, have them delegate proving to a network where there are capable machines that can do this, and you have a great user experience on the user side. How do we solve the problem of privacy then? How can this client give away the sensitive information to a random GPU to have it generate a proof? How do we secure that information? And to that end, we have this protocol, confidential proving delegation protocol, the CPD protocol, which says that there are two things. One is you take multiple machines and do computation across these machines in such a way that each machine does not learn anything about the sensitive information. You just mask the information in such a way across these machines so that they are capable of talking to each other and coming up with the proof finally, but none of them, even if n minus one of them get together, they don't know anything about the secret data. That is one part. The other part is that this works in tandem with the mechanism design, with the proof generation protocol that the base layer has. These two put together is the confidential proving delegation protocol. And currently we are focusing on Grot 16, but we have this vision of building an MPC ZKVM.
Witnessing some of your work, you're doing some like crazy stuff with multiple GPUs. Is that related?
For CPD, you mean?
Yeah, I mean, for, from our kind of like small collaboration, I've noticed that you have this, you are modifying like code 16 and just like, running some
Yes.
stuff in parallel on multiple GPUs. Just curious if this is like connected to CPD.
Yes. Okay. Let's get into the tech stack now of CPD. So there is CIRCOM. There are two implementations of MPC that we are using. One is from Taseo, and the other one is Dan Bonet and Alex Ozdemir's implementation based off of artworks. And then is Ingonyama's ICICLE. We put this all together and we make this really fast using Ingonyama's, your folks' ICICLE on the back end. And goal is good user experience. Good user experience has already come by delegating the heavy task away from the client, and you already get huge improvement. Now, for the protocol itself, how do you make proof generation really fast? How do you make sure that MPC doesn't bog down the proof generation, total proof generation time? And that is exactly where ICICLE comes into play. Each machine across these end machines, each of these machines are running a GPU, are running GPU accelerated implementations of these proof systems.
Got it. Okay, so Maybe let's take more of like a higher level approach, talking about the roadmap, because we've gone pretty deep on the technical topics, and I feel like trying to get a kind of like a good understanding of where you are on your roadmap would be useful. What are the next steps? What's going to happen in the next 12 months, and so on?
There are some clear next milestones: testnet to mainnet, CPD to mainnet. We are finishing up our integration with a bunch of our customers, and they will be sending proofs not only for on the testnet but also on the mainnet. That'll happen. This is just the initial outlook. There is so much brewing inside. MPCZ KVM is one thing that is starting to brew inside Fermah, and there is much more exciting stuff. I just yeah, there are a couple more exciting items, and I haven't ever been this excited ever in my life. So I am, but I will keep the suspense, and probably in like a few months we'll talk about it on your show again. Um, yeah, this is what is next, Omar.
We'll keep it under wraps for now.
Yep.
I think that we managed to cover quite a lot in this like short period of time. I want to ask you something that's a bit unrelated, more of like about company building. So I know that you've been in this accelerator by A16Z, and I wonder if you can share for the founders listening, kind of like more about the experience of building your company as part of or working with such an accelerator, if that's okay.
Yeah, absolutely. We have managed to build. I think one thing I'm proud of is that we have managed to build um, a no BS company where everyone is focused on moving the needle. There is zero politics. There is zero fluff. Everyone is just it's a happy, clear focus, small team, and I think probably that's our edge. We would like to stay small as long as we can. And CSX, folks at A16Z are um, extremely resourceful. I think the reason why we went with CSX is mainly because we got this official access to folks like Guy, Ali, Eddie, Pranav, Tim, Justin, amazing folks at A16Z. These are just the absolute real rock stars in each technology vertical. And these people are just in general very helpful. And to me, my initial access to A16Z was Professor Dan Bonet. And Dan I've known for a long, long time, and he's just very kind. And everyone there is just very kind in how they give their time. They just give time. They I don't know how they manage to do it. They end up helping everyone who comes to them. And I just wanted this official access to all of these folks. And we went through CSX. It was to me, CSX was more of an extension of the daily or weekly or monthly collaboration with A16Z. It just is a few weeks of intense sitting together of and that wasn't anything new because I went to the CSX program a lot after the company was incubated because it happened in New York City, and that was more amenable for me being in the US than I think the previous one was happening in London. I couldn't have commuted for sure from here, and yeah, we just didn't this 9 weeks or so of CSX, of 2 days per week of sitting together, and we would go over like product market fit. We would go over marketing. We would go over what is the right mental model for a founder to think about founder-led marketing. What is and they have been so helpful even in recruit. We found one of our engineers through them. I think they are this. How would I characterize A16Z folks? Is that they don't get in your way of operation, but when you reach out to them, they're there, and when they give you advice, it's dense and it's really impactful. Yeah, if you have any specific other questions about A16 CCSX, happy to answer. But I think takeaways that I would recommend it to someone who also, like me, appreciates access to folks like these, because they really, their advice is really dense and really high quality. When you seek something like that, it is good to. I think it is less of how do you build a company. It is less of teaching you. It is less of going through this course of building a company. It's very less of that. I really think it's just official access to these people. I think, to me at least, it was just that, and it was great.
Okay, so thank you for sharing. This was very eye-opening. And this also leads us to the end of this show. And we usually like to end with one final question, which we ask all of our guests. And this is to name a project or a product you're bullish about.
So 2 of the categories that I'm super bullish about are ZK Identity and ZK TLS. And under ZK Identity, one project I'm, of course, super bullish about. The project that is really leading the industry in that category is World Chain. They are super technical, but also understand their customers really well.
And with that, Vanishree, we'd like to thank you for joining us today. We learned a lot. I think you possess the unique combination of a scholar and a great educator, and we definitely like to have you here again to deep dive into mechanism design, which I think is a topic that we are only scratching the surface of at the moment. For those who are interested to learn more, I added some links in the show notes. And yeah, that's it. Thank you so much again. And thank you, Queenie.
Super. Thank you, Omar and Queenie.